Let's see this. See, so far we have seen that our RAM will be divided into frames and our process will be divided into pages, right? Where frame size equal to page size. Now let us assume we have a process named as process P1 and it has 5 pages. Okay, it has 5 pages. Now the question I want to ask you is whether all these 5 pages should always be maintained inside the RAM or not. Okay, see, what I want you to tell you is, see, either this process P1 can be either present in the RAM or need not be present in the RAM, right? It should definitely be present in the hard disk, no doubt about that, but it can be present inside the RAM or it need not be present inside the RAM. Now my question is, can it be the case where only some pages of process P1 will be in the RAM and some pages will not be in the RAM? Is it possible for such a scenario or not? That is the question. Okay, the answer is yes, it is definitely possible. That is what we mean by the concept of virtual memory. Okay, that is what we mean by virtual memory. We will see that. So what I want to tell you is, we have 5 pages over here, right? Let us assume, let me name these pages page 0, page 1, page 2, page 3 and page 4. Let us assume I have decided that I need to have page number 0 and 1 inside the RAM. Page number 0, page number 1 inside the RAM. It need not be present in contiguous allocation, right? So let me place it here. Page number 0 and page number 1 are present inside the RAM. One thing is for sure, all these 5 pages will definitely be present inside the hard disk, right? Whether a page is present inside the RAM or not, it doesn't matter, but all these 5 pages will definitely be present inside the hard disk, and these 2 pages will be present in both hard disk as well as RAM. That is what our assumption, that will always happen, right? In case if it is present in RAM, it has to be present in hard disk as well. Fine. So as of now, this is what the scenario. Now why are we doing this? See, this is definitely possible. Okay, the reason that why are we doing this is, we are going to get some advantage because of that. See, that is what we are going to see here. Principle of locality says that at any time a process will require only few pages, and these set of pages will gradually change over time. This is very important point. Okay, at any time. What does it mean? See, let us assume CPU is executing a process. CPU is executing a process. Now my question is, will CPU need the complete process at any given time? No, right? CPU will simply fetch a byte, right? It will simply fetch a byte and then it will execute it, and only after completing that byte, it will fetch the next byte, right? Now if that is the case, why are we going to maintain the complete process at every time? Rather, you simply maintain only some pages of a process and you maintain pages of some other process in the remaining space in the RAM, right? See, in case if I would have had all 5 pages inside the RAM size will get reduced, right? For other pages, I cannot maintain other pages. Now, because I am maintaining only 2 pages of process P1, I can maintain more pages of other process, right? So obviously what is actually happening here is, degree of multiprogramming is going to increase, right? What do we mean by degree of multiprogramming? Number of processes, maximum number of processes which I can maintain inside the RAM at any given time is called as degree of multiprogramming. Now by having only few pages of a process, I will be able to maintain more number of processes inside the RAM, right? So degree of multiprogramming is going to increase. See, what will happen if degree of multiprogramming increases? If degree of multiprogramming increases, we are giving more choice to our CPU to pick from, right? See, CPU will obviously, see, our scheduling algorithm will pick one among the processes to be executed by the CPU, right? Now in case if I have more number of processes inside the RAM, I am giving more choices for the scheduling algorithm, right? Our scheduling algorithm will get more choice to pick from. So because of that, what might happen is, see, let us assume we have decided that we need to place all 5 pages inside the RAM, right? I am going to maintain all 5 pages, P0, P1, P2, P3, P4, all of them are present. And now what, let us assume process P1 has gone to IO. Okay, process P1 has gone to IO. Now, what do you mean by IO? Reading something from IO device, right? Reading or writing something from IO device like hard disk, pen drive or whatever. That is what we have already seen about IO, right, in part 1 course. So let us assume this complete process, all 5 pages are present inside the RAM, and the process P1 has undergone IO, which means it cannot be executed by the CPU. Now what will happen? Let us assume we have only less number of pages. Okay, see 1 2 3 4 5. Let us assume we have only 5 frames in the RAM. It is just an example, right? It is not practically possible. And let us assume we have only 5 pages in our process. Now what I have done is I have placed all these 5 pages over here. So our degree of multiprogramming is only 1, right? Our degree of multiprogramming is only 1 because I am maintaining only one process in the RAM. Again, it is not practically possible. It is just, I am just telling these things to make you understand the concepts easily. Fine. As of now, we have only P1 over here, and P1 has process P1 has went to IO, right? So CPU is actually free, idle, right? CPU is not executing any process. Why? Because CPU cannot execute any process. The reason being, we are left with only one choice, which means our CPU has only one choice and it needs to execute process P1. But still it is unable to execute process P1 because process P1 has undergone to IO. Now why this happened here? Why CPU is idle here? Because the degree of multiprogramming is less, right? Now let us assume I am going to maintain only 3 pages of process P1 inside the RAM, okay, or 2 pages, P0, page 0 and page 1 of process P1. Let us assume I am maintaining, see, this is process P1, this is process P1, this is process P1, right? Let us assume I am maintaining page number 0 and page number 1 of process P2 as well. Don't get confused here. This is page number 0, page number 1 of process P2. This is page number 0 and page number 1 of process P1, right? Fine. Now what will happen? Let us assume process P1 has undergone to IO. Now what we will do is our CPU will execute process P2, right? Our CPU will execute process P2 and P1 will undergo IO concurrently. Both will happen at the same time, right? See, CPU execution and IO device can work at the same time. We have seen it a lot of times. So ultimately what is happening here is we are keeping our CPU busy, right? So CPU efficiency is going to increase by giving more choices for CPU, which means by increasing the degree of multiprogramming. Now why this happened? Why our CPU is busy here? Because we are left with 2 choices, which means the number of choices which our CPU has actually increased from 1 to 2. See, initially we had only one process for CPU to be executed. Now we have 2 processes, so in case if it is not able to execute one process, it has gone to the second process and it is executing it. That's the reason our CPU is busy now. So what ultimately I want to tell you is, we need to have the degree of multiprogramming, which means the number of processes inside the RAM as high as possible, so that our CPU will be left out with more number of choices to be picked from, more number of processes it can pick from, right? So by increasing the degree of multiprogramming, our CPU efficiency is going to increase. So this is the baseline, okay? We need to increase the degree of multiprogramming. Now what our principle of locality says is, one thing is for sure, at any given time, for example, in a time our CPU needs to execute a process, it will execute only 1 byte in a page, right? It cannot execute 10 bytes at the same time. Why? Because we have only one processor with us. So rather than having all the pages of a particular process, you can have only few pages, because at any given time our CPU is going to use only few pages. It is not going, see, I am not saying that here we have 5 pages and our CPU will use only 1 page. I am not saying that. I am saying that at any given time, that is why I underline this point. At any given time, I will either execute this page or this page or this page or any page, right? I cannot execute all 5 pages at the same time. Maybe in the future, I might have to change the other page, right? That can happen. So that is what I want to tell you. So what principle of locality says is, at any given time, our CPU will need only few pages of a process. So that is what principle of locality is saying. Now virtual memory concept has come from this derivation, right? See, principle of locality has said that at any given time you need only few pages of a process. Now because of that proof, our virtual memory concept has come in. Let's see what do we mean by this. We maintain only few pages of our process in the RAM. memory. Such a memory is called as virtual memory, right? So that is what I'm going to tell. See, in case we have our RAM, and in case if you allow that only few pages of process can be present inside the RAM, then we say such a memory as virtual memory. Okay, that is what virtual memory. See, it is simply the RAM. Memory is nothing but RAM. Fine. Now we can say this memory as virtual memory in case if you allow only few pages of a process to be present inside the RAM, right? Rather than putting a strict rule that all the pages should definitely be present. In case if you allow that, okay, only few pages can be present, few pages of a process can be present at any given time, we can say such a memory as virtual memory. Now in case if you put a constraint, if you put a condition that no, it is not allowed, I need to have all the pages of a process at any given time. I cannot have some pages. Either all the pages should be present or no page should be present. In case if you put a condition like that, then we cannot say such a memory as virtual memory. Okay. So we say a memory as virtual memory in case if that memory is allowed. See, it all depends on implementation, right? Some implementations, it all depends on the manufacturers, what they allow for a RAM. Some people might allow. Today everybody is using virtual memory. But if you go a few years back, what was actually happening is they were not using virtual memory. They were having the condition that in case if a process is present inside the RAM, all the pages of it should be present inside the RAM, right? It cannot have only few pages. So we were not using virtual memory before. But now what we are doing is we are maintaining only few pages of our process, and so we can say our RAM as virtual memory, right? Fine. So what is the advantage of virtual memory? Our degree of multiprogramming will increase. Now if our degree of multiprogramming increases, then our CPU has more choices to pick, more number of processes to pick from, right? More number of processes to pick from. So what is effectively happening is our CPU efficiency, which means the percentage of time CPU is busy, is actually going to increase, right? That is our ultimate goal, right? Our ultimate goal of our computer system is to have the CPU as busy as possible, so that our computer will be more faster. More busy the CPU is, more faster our computer will be, right? Fine. So such a memory is called as virtual memory, and the set of addresses or part of process which are inside the RAM is also called as virtual address space. Okay, it is also called as virtual address space. See, we have already seen what is meant by logical address space, right? This complete set, let us assume this is our process P1 and it has 5 pages. We have already seen that this is nothing but logical address space, right? Also we have seen that our set of addresses inside the RAM, physical addresses, we also say that as physical address space, right? We say this is physical address space and we say this is logical address space. Now in virtual memory, we are allowing only few pages to be present inside the RAM, right? Now actually page 0 and page 1 of process P1 is present. Now we can say this as virtual address space. Why? Because few pages can be present inside the RAM, and the set of pages of a process which are present inside the RAM is called as virtual address space. Okay. See, in simple I can say that the complete process is called as logical address space, and the part of the process which is present inside the RAM at any given time is called as virtual address space. Okay. What is meant by physical address space? The complete RAM, the set of addresses of the RAM is called as virtual address space. What is meant by logical address space? The complete process, which means the set of logical addresses or the complete process or set of logical addresses, both are same, right? And in case, let us assume we are using virtual memory and we are having only few pages of our process inside the RAM, then we say that few pages which are present inside the RAM as virtual address space. Okay, fine. So that is what I want to tell you. Set of addresses which are inside the RAM is also called as virtual address space. So principle of locality says that at any given time you don't need to have all the pages of our process, and virtual memory has actually implemented this, right? The memory which implements this principle of locality, we say that as virtual memory. Fine.